Alright, so in this video, I'm going to solve the equation 9 to the power of x is equal to 27. So to solve this, I'm going to first start by rewriting both of these in a base of 3. So 9 is the same thing as 3 squared, and 27 is the same thing as 3 to the power of 3. And the reason I'm doing this is so that if both the bases are equal, I can just set the exponents equal to each other and solve. So now I'm going to use the property a to the power of m to the power of n is equal to a to the power of m times n. So 3 to the power of 2 to the power of x is going to equal 3 to the power of 2x. And finally, I'm going to use the property a to the power of m is equal to a to the power of n. If this is true, this means that m is equal to n. So in this case, 2x is equal to 3, and if I divide both sides by 2, I get x is equal to 3 over 2. Alright, so in this video, I'm going to solve the equation 9 to the power of x plus 9 to the power of x plus 9 to the power of x is equal to 999. So to solve this, I'm going to first start by factoring out 9 to the power of x from the left-hand side. So I get 9 to the power of x times 1 plus 1 plus 1 is equal to 999. And 1 plus 1 plus 1 is 3, so I get 9 to the power of x times 3 is equal to 999. Now from here, I'm going to divide both sides by 3, so these two cancel out, and I get 9 to the power of x is equal to 333. Now 9 I can rewrite as 3 squared to the power of x. So I get 3 squared to the power of x is equal to 333. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of 2 to the power of x is equal to 3 to the power of 2x, which is equal to 333. And now from here, I'm going to take the log on both sides, so I get log 3 to the power of 2x is equal to log of 333. And if I have something in the form log a to the power of b, I can move this exponent b to the front, so I get b times log a. So in this case, I have log 3 to the power of 2x, and I can move 2x to the front. So I get 2x times log 3 is equal to log 333. Now I'm going to divide both sides by log 3 because we're isolating x. So these two cancel out, and I get 2x is equal to log 333 over log 3. Now I'm going to rewrite log 333 as log of 3 times 111. And if I have something in the form log a times b, this is equal to log a plus log b. So I get log of 3 plus log of 111 over log 3. And this is equal to 1 plus log of 3 plus log 37 over log 3, which is equal to 2 plus log 37 over log 3, and meaning x is equal to 1 plus log of 37 over 2 times log 3. Alright, so in this video, I'm going to solve the equation 27 to the power of x minus 3 to the power of x is equal to the square root of 2. So to solve this, I'm going to first rewrite 27 as 3 to the power of 3. So I get 3 to the power of 3 to the power of x minus 3 to the power of x is equal to square root of 2. And now from here, I'm going to rearrange these. So I get 3 to the power of x to the power of 3 minus 3 to the power of x is equal to the square root of 2. Now I'm going to let 3 to the power of x equal to the variable y. So I get y to the power of 3 minus y is equal to the square root of 2. And this means that if I square this on both sides, y to the power of 3 minus y squared is equal to 2. So now if I have something in the form a minus b squared, this is equal to a squared minus 2ab plus b squared. So this is going to turn into y to the power of 3 to the power of 2 minus 2 times y to the power of 3 times y plus y squared. And this is equal to y to the power of 6 minus 2y to the power of 4 plus y squared minus 2 is equal to 0. Now from here, this turns into y to the power of 4 plus 1 times y squared minus 2 is equal to 0, because we just factored by grouping. So now I get two equations. I get y to the power of 4 plus 1 equals 0, and y squared minus 2 is equal to 0. So for y squared minus 2 equals 0, all I have to do is add 2 on both sides, and I get y squared is equal to 2, and if I take the square root, I get y is equal to positive negative square root of 2. So this is my answer for this. These are two solutions, and for two more solutions, I'm going to rewrite this as y to the power of 4 is equal to negative 1. And now from here, I'm going to rewrite y to the power of 4 as y to the power of 2 to the power of 2. Now, if I take the square root on both sides, I get y squared is equal to the square root of negative 1, meaning y is equal to I. So these are my three solutions to this equation.